So today we will be starting with the topic called as VPN. Very important. But before you need to know about VPN, one also very important topic which needs to be get considered and which needs to be known, that is called as cryptography. Okay. I don't know how many of you know about what is cryptography, but it is the heart. This is the base of the VPN. Base of the VPN. Because if this is not cleared, cryptography is not cleared, nothing can be cleared. Trust me. This is the most important thing. And as we move further ahead, this will be very important in VPN as well as in next generation firewall. Okay. So this cryptography word na actually has come from the word called as cryptos. Cryptos means hidden secret. And the another word which is being used is called as graphene. Graphene means to write. Combination of, and this is a Greek word, in Greek language. So cryptos, graphene has become a word called as we moved ahead, it has become and called as cryptography. So basically, it's the practice and study of technique for secure communication. Okay. The main goal of cryptography in today's world are three. First, confidentiality, integrity, and third is authenticity. This we also call as CCIE Triad. Okay. These three things are important. So what is confidentiality? Confidentiality is basically if a packet is moving from point A to point B, the data should not be seen by anyone in transit. Like we say that na, or the data can be open only by legitimate users. So say for example, we call now sometimes there is a confidential, we have a confidential data. What do you mean by confidential data? That someone should open it, but not everyone will be able to see it, right? Someone should be able to see it, but not everyone. That is called as confidentiality. So how you achieve confidentiality, I will explain that as we move further, but this is called as encryption. Encryption is being used in order to achieve confidentiality. That means data in the internet will not be able to seen by anyone. If I encrypt a data, if I put a confidential paper in an envelope and I make a seal of it and then I send it towards somewhere else, no one in between will be able to open the seal up. And then only to whom I have sent it, that XY guy will be able to do that. Got it? Next is, yes, let's start it. So, cryptography, right? I have told you. And the main concept of the cryptography is CIA. Main goal of cryptography is confidentiality, integrity, and authenticity. Okay. So let's start with the word called as confidentiality. How you achieve confidentiality? By doing the encryption. By doing what? Encryption. Encryption is a process. First, start with this. It's a two-way process. Why I say it's a two-way process? Two-way process in the sense, you see at one end we do encryption, the other end we do de-encryption. You heard about both the words, right? Encryption, de-encryption. It's a two-way process. Encryption is basically a subset of the word called as encoding. You might have heard about the word called as encoding. It's same. Encoding is also a two-way process. Encoding, de-encoding, right? Basically, encoding is a process in which you change anything from one format to another format. What is the meaning of that? One format to another format? Meaning. Think in a way, in your physics, in your good old days, you might have seen that wind energy is getting converted into electrical energy. Correct. Mechanical energy is getting converted into kinetic energy. These all are called as encoding, right? So encoding is something which changes from one format to another format. In our world, in our networking world, you might have heard about a word called as SFP, small form factor pluggable unit. So SFP is the place where you put it, where it's these are expensive. Dollars I'm saying $1,000. You will see that SFPs are very expensive, $400 to $1,000 range, depending on SMF and MMF, single mode fiber multi. So what this SFP? In this SFP, always there will be an encoders. So what they do in the SFP, if you putting MMF cable or SMF cable, single mode fiber, multi mode fiber, what is this fiber cables? What we call that fiber? Fiber cable is the cable in which the data is getting transmitted in a form of light. And when you put SAP into the networking device, the data is converted into what? Electrical bits. So this SFP has encoder which convert light into electrical bits back to the light. So in a very similar way, encryption is a two-way process and it is a subset of encoding. Meaning, if I have a data which is in plain text format and I wanted to send this over the internet, but I wanted to achieve confidentiality. So what I will do is, I will convert this plain text, put it into the encryption algorithm, and I will convert this into cipher text. So definition, whenever a data, a plain, what do you mean by plain text? A text, a data which is human readable format, which we as a human can read it. Human readable format. So whenever you are converting a plain text into the cipher text, this concept is called as this concept is called as encryption. And if goes from cipher text to plain text, this is called as de-encryption. Okay, so two-way process. Over the internet, the cipher text will not be able to see by anyone. So encryption and de-encryption. Plain text to cipher text back to the plain text. And with this, we achieve confidentiality. Next. In order to do the encryption, one fundamental golden rule I will tell you. One rule. Very simple. What? In order to do encryption anywhere in on planet Earth, I will say two things are mandatory, not best practice, mandatory. One, you need an algorithm to encrypt a packet and you need a key. Remember that. You need any one thing. If you have key but you don't have algorithm, encryption cannot be done. And if you have algorithm but you don't have the key, again, nothing can be achieved. So you have a lock with the key. Both are required. Then only you will be able to safeguard your house, right? Both are important. Similarly, encryption also, both the things are mandatory. Both are mandatory things. Next. Encryption are of two types. Symmetrical and asymmetrical. Symmetrical encryption, or you can think in this way. I'll write in this way only. Algorithms and keys. So algorithm are symmetrical algorithms and asymmetrical algorithms. And keys also are two types. Symmetrical keys and asymmetrical keys. What are the examples of algorithms? Symmetrical algorithm. DES, 3DES, AES, ChaCha, Poly, RC4, RC5, Bluefish, and so on and so forth. 99% most of the people generally use AES because it's well known, well renowned, proven concept. Okay, next. What's next is asymmetrical algorithm. What are those? RSA, DSA, Diffie-Hellman. These are the three things that we have it. So RSA, DSA, and Diffie-Hellman. Acha sir, how this works at the back end? Okay, how this algorithm works, that I also don't know, and that's not our forte. People does MS in crypto analysis for 2 years. MS happens. Well known is in Germany. In order to know these algorithms, you should be master of mathematics, a primitive root, prime factors, all those things. I know what is the use of the algorithm, but how this mathematical operation works on the motherboard, so that's not my subject, to be honest. Okay. And symmetrical keys are, what do you mean by symmetrical key? Same key will be used for encryption and de-encryption. Whereas asymmetrical means a pair of key will be there. What do you mean by a pair of key? Public key and private key. So one of the key will be used to do the encryption, the other key will be used to do the de-encryption. Symmetrical algorithms will always use symmetrical key. So you will see that AES will never see public and private. You will never see. An asymmetrical algorithm will always see asymmetrical key. Remember that. Okay. So symmetrical algorithms and asymmetrical algorithm. Now, which one to be used? Let's talk on that. The size of the key for symmetrical key is from 80 bit to 80 bytes to 512. And asymmetrical size of the key is from 512 to 4096 bytes. You might have seen the command. Array, this to 100% most of the people might have done in their CCNA. You should know how to enable SSH on the router, right? You might have done in CCNA routing switching. How to enable SSH. So to do the SSH, you used to give one command, right? Crypto key generate RSA modulus. Then you give modulus 1024. What is this 1024? It's the size of the key. And what is RSA? RSA asymmetrical. So size will start from 512 to 4096. So higher the size of key, okay? Higher is the size of key, more secure you are. So assume that there are two gates and two doors. One door has 6 locks, another has only 2 locks. So what is the disadvantage here? It is less secure. What is the advantage here? It is more secure. But what is the advantage of this? Fast. What is the disadvantage? Latency. So I am going to write and tell you a very important point. In production or anywhere in the world of networking itself, I am saying data plane is there and control plane is there. Control plane is being secured and you achieve confidentiality in control plane always by asymmetrical algorithms. You will see always a symmetrical thing. But for the data plane, and data plane will be always secured with what? Data plane will be secured by always symmetrical algorithms. You never use for data plane asymmetrical. You will never see RSA and DSA or Diffie-Hellman used for data plane. Because if for data plane, if you start using this, the latency will go big time. So all symmetrical algorithms are used to provide protection for data plane. Control planes are important. See, if you talk about first how you initiate the things, always you initiate the things with the control plane, right? Correct, na? Control plane are the most important thing. If control plane is any hijacked has been done over there, then the data plane to always going to be get compromised. So control plane are more important than the data plane. I'm not saying the data plane is not important, but they are limited also. You will see always the control plane messages are limited numbers, 2 messages, 3 messages, 10 messages maximum, right? And when we say that this uh, asymmetrical, it's not always about the control plane also. We generally use this in the world of PKI for doing the authentications with the digital certificate, and more in detail I'll tell you as we move further, right? But control plane, the number of messages are less. It if we have reached to 4096 also, right? It hardly add any latencies because we talk about latency on the data plane. We don't add and talk about latency on the control plane. First TCP three-way handshake will happen, then only your data plane will start, right? So that's what the main important part. So basically control plane is the most important thing. If that itself get hijacked, the data will hijacked immediately, right? That's one of the reason. Plus another reason in the world of PKI, I'll tell you. Just give me a minute. Next. So this is important, encryption. So you should remember that AES will need only one key to do both the process. Okay, next. Another important thing to understand is integrity. What is integrity? Whatever the data is there, if that is moving from X towards Y, in transit the data should not be altered. Data should not be changed. Okay. Data should not be manipulated in transit. I am sending data high. Someone over the internet has changed the data to high and send it towards the destination. This is called as compromise of integrity. Your integrity has been compromised. Fair enough? Next. Reduce or anything. If data has been seen, data has been manipulated, reduced or increased, sir, anything. Any change in the data, sir, plus minus, integrity has been compromised. Okay. To start with, unlike encryption, acha, integrity will be achieved with what? Integrity will be achieved using hashing algorithm. Example, 100% you might have heard about MD5 and SHA. Most of the people are always confused like MD5 and SHA are what? These are not encryption, sir. These are not encryption. These are integrity algorithms. These are what? Integrity algorithms. So these are hashing algorithms which is being used to achieve integrity. Very important point. Hashing algorithms are one-way process. Encryption are two-way, hashing is one-way. You ever heard about a word called as dehashing? There is no such word called as dehashing. Got my point? There is no such word called as that. Okay. So it is a one-way process. Next. So it's like you have coffee beans. From coffee beans, you can make coffee powder. But from powder, can you make beans back? No, can't. You can't do that. Next. How this works. If you have any data, you put that data into the hashing algorithm and it will generate some output. Remember, when you put data into the encryption algorithm, what do you call that output? That is called as ciphertext. These are interview questions, okay? That is called as ciphertext, okay? But if you put any data into the hashing algorithm, there are the one big name which is called as digest. But this digest have multiple names depending on where you are using this particular hashing algorithm. So if you are using the hashing algorithm in the world of software downloading, this is called as, you might have heard about a word called as checksum. So the digest in the world of software is called as checksum. If you are using this in the world of PKI, this is called as fingerprint. This is called as fingerprint. If you are using this in the world of antivirus and anti-malware, these are called as virus definitions. And sometimes these are called as signatures. Fourth, what is fourth? If this is used in the world of VPN, this is called as integrity check value. Achha, these are na very important points we are learning right now. Trust me, you have to remember this as we move further ahead. So, if any data that you have it, whatever the data you have it, that data, if you put into the hashing algorithm, the output is called as digest, and depending where you are using it, the name gets changed. Assume that this data, which is being put into the hashing algorithm, we have generated a digest for the same. This data over the internet, this data along with the digest will be sent. Assume that the digest is 1, 2, 3, 4. So digest will go. Point to be noted. The data goes as it is. The data goes as it is. It is not encryption. Along with the data, 1, 2, 3, 4 will go. When the recipient is going to receive this, so I will take the data, but I will accept it only when I'll put the same data into the hashing algorithm and we will generate the digest. If the digest which is generated by the recipient and the digest which is being received along with the data, if both match, the data will be accepted. If any change in that, the data will be dropped. Example, I have VLC media player. Everyone knows about it. Everyone has heard about it, VLC media player. So when you go to the legitimate site, and you click on download VLC media player, you see it's getting downloaded. But thanks you download, display the checksum. There you see it's a checksum. So once this is being downloaded, before I install it, I will check. So it is coming from where? You see what is happening. My PC over the internet reached to VLC website. I am trying to download the data, but along with the data, the checksum value is also there. So once I receive the data, I will put that into the same MD5. So whatever the checksum which is being defined on the website, and whatever the checksum which I'm going to generate it, if this value is same, that means integrity of the program has been achieved. That means over the internet, no one along with this vlc.exe file has added any malicious content. It is whatever the website is telling from the website over the internet till my laptop. No manipulation, no addition, no subtraction, nothing is being done. Okay, it is used, no, multiple places, David, can be used. I will tell you that where can be used. But first, let's understand what is this. Okay, next. Give me a second. Now what's next? So hashing is used to achieve integrity. But hashing does not provide pure integrity. Now, and let's try to understand this concept. There is a word called as spoof. There is a word called as spoof. Spoof means is stealing someone's identity. Stealing someone's identity. That means, assume that I'll draw a scenario. There is a Bob and there is Alice. Bob IP address is 1.1.1.1. Alice IP address is 2.2.2.2. And there is in transit Nitiz. My IP is 3.3.3.3. I am doing man in the middle and I am a hacker. The first thing that the Nitiz is going to do is, I will find a vulnerability. You might have heard about this word, vulnerability. What is vulnerability? Vulnerability meaning is weakness. No, no, sir. Vulnerability meaning is weakness. I am vulnerable to cold. Just to give you an example, sir, right? That is, it is my weakness. Okay. So if I want to attack on someone, if I want to attack someone, so first I will do the scouting. First, what I will do is I will do the scouting or I will do recce to understand their patterns, to try to see that what are their day-to-day work and all this, right? And from that, I am going to find what is their vulnerability, what is their weakness. Okay. What is their weakness? And once we found the weakness or the vulnerabilities, then we are going to exploit that weakness. And then I got a way to find this particular IP address. So what Nitiz did, I did the spoofing. I stolen the identity of the Bob. The first thing is that only I did. So Nitiz now know what is the IP address of the Bob. Second thing, Bob sent the data high and he put the data into the MD5 and it generates the digest which is 1, 2, 3, 4, 5. Bob sends the data high with the digest. Once it sends into the internet, Nitiz intercepted it. I intercepted the data. I manipulated the data. I changed the data and I changed now my source IP to 1.1.1.1. The destination IP address is 2.2.2. Now I destroyed the data as well as the digest. I created a new data. I created a new digest 3, 4, 5, 6 and send it to the Alice. Can I intercept the data in transit? Yes. Linux, kernel based Kali Linux. This is what in ethical hacking you learn about. Kali Linux. So many tools are there which can intercept it. If my source IP is this, can I create and generate a packet with a different source IP address? 100%. 100%. So Nitiz, as an attacker, I destroyed and intercepted the data as well as along with the digest. I generated brand new some data which I want Alice to accept. And I put that data how into the hashing algorithm and I generated a digest 3, 4, 5, 6. And that I sent to the Alice. Now what Alice say? The moment the Alice receives it, the moment the Alice receives it, it is going to take the data, how? Put into the hashing algorithm and generate the digest 3, 4, 5, 6. The digest which is being generated by the Alice and digest which is being received by the Alice, both are same. So Alice thinks that integrity has been achieved. But even though, what is the problem? The actual data which Bob has sent is never being achieved. So hashing does not provides you pure integrity. So what they did, when both these Bob and Alice wanted to communicate, they will, for the authenticity that we are communicating with the correct guy, they exchange one key with them. That is called as message authentication code. One code they will share. How they will share, I will explain it to you when I move further ahead in the world of VPN. So they will be doing what? They will exchange the key. They will exchange this message authentication key, and only these two knows. Nitiz will never come to know about it. So there is a data high along with the key put now into the hashing algorithm, and now they will generate the digest. So now this data high will go with the digest. So when Alice receives it, Alice will put the high, Alice will put the code, MAC code, put into the hashing algorithm and generate the digest. So this will be exactly same. Now assume that if Nitiz is trying to do the same thing what he did earlier, but does Nitiz has that particular MAC code? No, I don't have this MAC. So if I receive this data with the digest, if I destroyed it also, and if I send the new data, how? But I don't have the code. I don't have the message authentication code. So I will just put the data into the hashing algorithm. I will just generate a digest. Now what I'll do is I will send this data with this digest to the Alice. When Alice receives it, she will put this data, but she has the code which both Alice and Bob only agreed. So if any change in the input, the output will be changed completely. So when Alice receives this how, when she put this data into the hashing algorithm along with the code, some other digest will be there. So Alice will say, Baba, this is not I'm going to accept. There is a change in the data that you are sending and what I have it, what I generated, digest are different. That's how the integrity is being achieved. So in year 2026, we are moving. When we want to achieve integrity, we achieve authenticity along with that. So in CIA, I and A are always achieved together. And how you achieve? H for hashing and MAC for message authentication code. You might maybe have heard about this word before. This concept is called as HMAC, hashing message authentication code. What is this called as? Hashing message authentication code, in which the data integrity and data authenticities are going to work together. That's how it is going to work. Okay. So what we learned in today's lecture, for HMAC, everywhere it will be tested. See, HMAC is not like testing. You will be tested on VPN. VPN integrated part is CCIE only. So encryption, HMAC will come 100%. So these are algorithms. They will not test you on algorithm. They will ask you to use this algorithm in the VPN. Okay. And that's for the day. All good? Got the basics done? And if these basics are not cleared, the next VPN will be bouncing from your head. Trust me. And so many people doesn't know this. See, this today's lecture, na, honestly, sir, with all due respect, has nothing to do with CCI. Correct? They will not ask you any Viva question and all those things. But as we move further in, now my base, I have made it clear. I made my base clear. So when I'm going to explain the VPN, the things will be very easy for you to understand also, for me to explain also. That's the reason we did this. Okay? Chalo. That's it for the day.